Okay. And what we did earlier is the first order or the first partial derivative. Like put it here. So the first partial derivative, there are two of them, right? Partial derivative, I cannot spell derivative. So there will be two parts based on z equals f of x, y. So the first one is the first derivative with respect to x, or the f and subscript x. And the second one with respect to y, or the f subscript y. This is what we saw in the earlier part of the package. But this time when you go to the next order or the second order partial derivative, that means you're going to find the derivative on top of the first partial derivative. So as a notation here, you see the f subscript x and x. So you go by the inside one and then do the derivative on top of it with respect to that variable. And where the notation with the curl or the d by dx operator is from the partial derivative with respect to x of the partial derivative with respect to x. So you're gonna find the first derivative and then do the derivative on top of it. So that's how you derive this notation. And the second one is you find the derivative with respect to y of the derivative with respect to y. The third one, you're gonna do the partial derivative with respect to x on top of the derivative with respect to y. It sounds confusing, right? And the next one, partial with respect to y of partial with respect to x. So you see the order of the derivative with respect to is different for the notations. If you do the partial derivative order or the operator, the quotient order here, it's from the right to the left. Like if you have the combination like this, you're gonna do x first and then y later, where the notation with the subscript, you do from inside out. So this x first and then y later. It sounds confusing, but pick one. Use one. Don't try not to do both at the same time. So when the problem said find all second partial derivative, you have four of them you have to find. Okay, so for the function that given, that means you're gonna find the f x x f. Just make a list like the four combination f x y, f y y, and then f y x. You see the notation is the combination of x and y. So you have four second partial derivatives. Don't even think about the third partial derivatives, and no worry, I'm not going to let you work on those. So just up to the second partial derivative. And for this particular problem, let's work on, just use the subscript notation here, okay? It's maybe easier to work on because you're gonna work from the inside out. Like for this one, the fxx here is from, you find the fx first, and let me put on the notes here for the, before you find the second derivative, you're gonna have to find the first derivative to begin with. So I'm gonna make the list on the side here for the first derivative. Since you're gonna have like two of them for the first derivative, the f subscript x, which is the partial derivative for the first derivative, is not a big deal because there's only one round of doing that. So the partial of x to the fifth times y plus 6x y to the third. Okay, and when you look for the partial with respect to x, you're gonna look at the term involving x, treat the y as a constant. So y here as a, this time is gonna be constant multiple. Okay, constant multiple. And you just target on the x here, the x here. So the first partial derivative gonna be x to the fifth, which is 5x to the fourth, and then multiply by y as a constant multiple, plus the derivative of the 6x is 6 multiplied by y to the third. And then for the next one is the partial with respect to y is x to the fifth times y plus 6x times y to the third. The y is the target. So you work on the derivative of the one involving y. So the x to the fifth is treated as the constant multiple. So the same thing, constant multiple. Then the first partial derivative with respect to y going to be x to the fifth multiplied by 1 from the derivative of the y. And then plus the 6x as a constant multiple multiplied by 3 y to the second from y to the third. Just clean up. So in summary, we have fx or the first derivative as 5x to the fourth times y plus 6y to the third. And then the partial with respect to y is x to the fifth plus 18 x y to the second. Okay, we set this aside. And then we're going to use them to find the second, like all second derivatives or second partial derivative. Different colors. So for f, xx, if they have the same variable, that's not too bad because we don't have to worry about which one first, which one last. So this one means to start from the inside out. So fx first and then x again. That means you do the partial derivative with respect to x of 5x to the fourth y plus 6y to the third. With respect to x, target the x, y gonna be the constant. This gonna be treated as a constant multiple because it's multiplied with the x term. This one gonna be considered as a constant in general because c constant, y constant, so constant in general. So the second partial derivative with respect to x is 5 times 4x to the third times y plus 0 or 20 x to the third times y as the fxx. That's the first, second partial derivative. Okay, that box is out. So this is one of them. And then the next one, fxy. This one is fx first and then y later. Or the partial with respect to y of 5x to the fourth y plus 6y to the third. This round, we target the y, we target the y, target the y. We treat 5x to the fourth as the constant multiple, the same as the value 6. Then the partial derivative will be 5x to the fourth multiplied by 1 because the derivative of the y is 1. And then plus 6 times 3y to the second. Now we get 5x to the fourth plus 18 y to the second for the second partial derivative with respect to x with respect to y. Okay, 2 down, 2 to go. Next one is fyy. Again, you have the same variable. It's not a big deal. You just repeat with the same variable. So partial derivative with respect to y of the fy, which is x to the fifth plus 18 xy to the second. So treat y as the variable. The rest gonna be the constant. stand alone can be constant alone, and 18x is going to be the constant multiple. Derivative of x to the fifth is 0. Derivative of the next one is 18 times x times 2y. Now we have fyy, or the second partial derivative with respect to y, as 36 times x times y. Okay. And then one more, the last one, which is f of yx, not f of fyx, which means the second partial derivative with respect to y first and then x later, or the partial derivative with respect to x of the fy, which is x to the fifth plus 18 xy to the second. And what we have here, we have x as a variable here, variable. We treat y as a constant, multiple. Sorry, I should circle wrong one. There you go. Okay, there you go. So we're gonna treat x as the variable, and then the y gonna be the constant multiple or the coefficient. So then we're gonna get 5x to the fourth plus 18 times 1 times y squared, or 5x to the fourth plus 18y to the second as the second partial derivative with respect to y and then with respect to x. And as we found all of them, we noticed that fxy is the same as fyx for the continuous function.